In this video, I'm going to go over the quiz that we had on Friday. We didn't have a whole lot of time to finish it, but let's go through it a little bit. Now, when they say sketch the angles in standard position, that means, well, we start here with 0, and we count this way in the positive direction. If we're counting in a negative direction, then we're going to go in this direction. So first one is positive 170. If this is 0, then this is 90. This is 180, so 170 would be right about here. Whoops, let me make a better line than that one. So that would be from here out to about 170. So it looks something like this, 170. Technically, we need to make this little mark here, right here. So that's what we do for the first one. Second one, I'll do in a different color here for a negative 170. Negative 170 means instead of going in this direction, we're going to go down this way, negative direction, this way 70. So that would be negative 90, so negative 70 would be about right here. Negative 70. Now technically we should draw it this way, starting here, going this direction. That's negative 70. I forgot to put the little arrows. Usually we put the arrow at the end of where the angle goes, so I do that. Next one is 440. Now there's a couple of ways to do 440. One method that's actually probably easiest for people is to figure out where this goes in the circle. So I can say this is 0, that's 90, that's 180, that's 270, that's 360, that's 450. So 440 would be right about here. This is 440 degrees. And what actually we'd do, technically we'd start here, we'd go like this, and then here, and then around here again to here, and that's what it would look like when we do it. Sometimes what people like to do to get an idea of where this is supposed to be is put a coterminal angle. So they'll say 440 minus 360, and they'll get 80 to 80. So this is the same thing. This is the same thing as 80, which we know is right there. Okay, let's look at some of the other problems. This one here, they ask for the measure of angle A. So I look at this and I say, well, based on this angle right here, this is the opposite, and this is the adjacent. So opposite and adjacent is tangent. So I'm going to say tangent of A equals 5 over 12. Now, when I do that, I have to do inverse tangent, so I type in the calculator tan negative 1, which is basically second tan. So I go second tan 5 divided by 12. So second tan of 5 over 12 equals, and what I get when I do that, I get 21.6198, 21.6198. But that's not how we would write it, because 0.61 is decimal. They want the nearest minute. So then we go in our calculator and we do second angle or second apse, and then down to degrees, minutes, seconds, and then we end up with 22 degrees, 37 minutes. We got to practice using that a little bit on the calculator. What is the number of degrees? So basically we're converting from radians to degrees. So from radians to degrees, we want to go into degrees. We start with what's given to us, 5 pi over 9. We multiply times, in this case, into degrees would be 180 over pi. If we wanted to go to radians, change to radians, then we would put pi over 180. Whatever we want to end up with should be at the top of our fraction. Pi's are going to cancel. So 5 times 180 divided by 9 is 100, so it's 100 degrees. Next problem, what is the radian measure of the smaller angle formed by the hands of a clock? Okay, this one's confused a lot of people, because here's a clock. That's 12, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the numbers on the clock here. So there's 4 o'clock. The hands of a clock would look like this at 4 o'clock. So I want to know what's the measure of that angle, and then change it into radians. So if there's 360 degrees all the way around, I divide it by 12. Each one of these is 30 degrees. So I say 30 plus 30 is 60, plus 30 is 90, plus 30 is 120. So basically they're saying take 120 degrees and change it into radians, which means I say times pi over 180. So that's 120 pi over 180, so I can reduce 120 over 180 to be 2 over 3. So it's 2 pi over 3 would be my final answer of that one. And that's what we get there. Next problem here, we're using the same triangle, but we want to find the secant of A. To find the secant of A, I don't know the relationship, but I know secant is tied with cosine. So it's 1 over the cosine of A. 1 over the cosine of A. So let's figure out the cosine of A, and we'll just flip it upside down. So cosine of A equals adjacent over hypotenuse, which we don't know the hypotenuse yet. I got to figure out this h here, hypotenuse. So I'm going to say 5 squared plus 12 squared equals h squared. 25 plus 144 equals h squared. 169 equals h squared. So let's take the square root of both sides. So if I take the square root of this and the square root of that, I get 13 equals h. So this length is 13, which means the cosine of A is, here's A, cosine of A is adjacent over hypotenuse, which is 12 over 13. So the secant flips it upside down. So if I flip 12 over 13 upside down, I get 13 over 12, and that's the answer I'm looking for. Whoops, let's put that back. Okay, that's that one. This one here, radian measure. What is a radian measure? I want to change negative 510 degrees into radians. So I start with negative 510 degrees. Into radians would be times pi over 180. So basically that means negative 510 over 180, and there's a pi here. So to reduce this fraction, what it becomes is 17 over 6 when I work on my reducing, and it's going to be negative, so the answer would be negative 17 pi over 6. Okay, the next one here, the exact value is secant of 210. Well, I don't know what the secant is on a calculator. I don't have a button for that, but I do have a button for cosine, so it's going to be 1 over the cosine of 210, and the cosine of 210, there's a couple of ways to do that, of 210 degrees. One method would be to figure out the reference angle is 30 degrees, so it's going to have the same thing as a cosine of 30, which is square root of 3 over 2, but it's in the third quadrant. We learned a quicker way to do this. If we go straight to our calculator, we get negative 0.866, 0, blah, blah, bunch of stuff like that. And I know that this is approximately the square root of 3 over 2. So basically, it's going to be negative square root of 3 over 2. Once I know that for the cosine, then I know that the secant is going to be 1 over that. So flip this upside down, and I get 2 over the square root of 3, which we really don't want to leave like that. Negative 2 over square root of 3. I multiply the top and bottom by the square root of 3 to get rid of that square root on the bottom. So the top is going to be negative 2 square root of 3, and the bottom is going to be 3. Square root of 3 times square root of 3 is just 3, so that would be my final answer officially. If it's multiple choice, this is the one that'll be there. Okay. Number 8 says determine the number of degrees, so we want to change into degrees. We multiply by 180 over pi. Now here's the tricky part here. We're always used to, we start with 5, and then we say times 180 over pi. And what we do is multiply 5 times 180 is 900. But we haven't canceled the pi. Usually when they start with radians, we have a pi here, but this one doesn't. It's kind of a trick question. So the answer will be 900 over pi. So that would be our final answer to that one, and it would look like that. When drawn in standard position, which quadrant will the angle Q terminate if the secant is positive and the tangent is negative? We learned a little way to do this with our what things are positive. We learned this, all students take calculus. So all means the sine is positive, cosine is positive, and tangent is positive. Over here, all students, so S students stands for sine, so sine is positive, and the cosine and tangent are both negative. Here, the tangent would be positive, and the sine and cosine are both negative. And here, all students, that's S, take T. Calculus C is going to be positive, and the sine and tangent are going to be negative. So for this one, they're talking about the secant being positive. Well, the secant's tied to the cosine. So where is the cosine positive? The cosine is positive in this quadrant here and this quadrant here. And the tangent is negative in this quadrant here and this quadrant here. So the only one with two dots that contains both of these statements is the fourth quadrant. So that's 4. We write Roman numerals for those. Number 10 is a little tricky. It's something we hadn't gone over enough, and I do have to go over more of that. Secant and cosecant are what we call cofunctions. And what that means is that if the two angles are supplementary, meaning if they add to 90, then the answer will be the same, the secant of this. So basically, if we add together m plus 90 minus m, we just get 90, which means these two angles are supplementary, so then this number is the same for both of them. So the answer will just be 4/7. Okay, and now we're looking at reference angles. When we do reference angles, what we'll do is figure out where's 110 degrees. It's right up here. So this is 110. And we always want to figure out the angle made with the horizontal. This is 180, this is 110. The difference there is 70. So that's the answer we're going to look for the reference angle. And in this one, we have negative 300 degrees. If I were to graph that, I'm going this direction. That's 90, that's 180, that's 270. There's 300, negative 300 degrees. And I guess all the way around would be negative 360. The difference between these guys is 60 degrees, so that's the answer there. So that would be the answer to all the problems on the quiz. Hopefully we can get 100% on that if we retake that quiz.